And we're live. Okay. Yeah. Apologies for showing up a little late again today. I might have taken a nap on the wrong side of campus and had to make my way over back to my place in somewhat short fashion. Anyways, this is day 100 of studying compilers every day until I land a compiler role. Yeah, it's quite incredible that I've gone this long. If you told me that my channel would have blown up as much as it has, when I first started, I probably would not have believed you. So it's just really cool to see how far I've come, and yeah, I guess none of this would have been possible without any of y'all. So thank y'all so much for, I guess, being along for the ride. Yeah, unfortunately this celebration is cut a little bit short because I have this nice little thing called another exam to worry about tomorrow. So yeah, I need to, I guess, be somewhat brisk today. The final I took today went pretty well though, so that's all good news. I felt like it went well at least. We'll find out how it actually went when scores come out, but yeah, it'll be a bit until it happens. Yeah, anyways, last time we looked a little bit more at how memory instructions worked, and we added a memory operand to our, I guess, parts of our language, I guess, sort of. Yeah, so we added that. This time we need to fix some things to actually use that memory abstraction properly. What's good, Neeraj? Thank you all for the happy 100s. Yeah, so we're gonna be fixing calling convention today. So yeah, that is the unfortunate reality. I wish I could spend more time just like sitting on 100, but I got places to be, unfortunately. So yeah. So we have a couple of to-dos, and they all live in the back end. Yeah, we're gonna need to figure out a way to allocate stack space. Good luck on the finals. Thank you. Yeah, I need to figure out what to do with this. How'd you do? I thought it went well, at least. There were a couple trick questions. The prof realized halfway through that he might have made it a little bit more difficult than he intended, so he gave us a couple hints. Overall, I thought it was pretty reasonable as an exam, so I can't really complain. Yeah, that's kind of like my little ramble about it, at least. How do we generate? I guess, what do we want to generate here? What was on it? Oh, was it on? It was just like a bunch of deep learning stuff. So like GANs, transformers were a pretty big part. There's a little bit of like deep reinforcement learning. Yeah, it was just like a whole pile of like deep learning topics. So I guess if you have questions about machine learning from a theoretical perspective, I guess you can ask me. I'm not really sure how well I could explain things, but I could at least give it a try, at least. I guess it's a really funny outcome because I've spent a lot of time specifically running away from machine learning related things. So yeah. Let me raise my mic. Yeah, okay. Okay, what was I guess, which of these to-dos do I want to work on? I should definitely do these first, I think. I could also modify these to just like straight up take a virtual register. Just from like the LIR abstraction I have here. Is ML power of compilers? You might be, I'm not sure what you mean by ML here, like machine learning or like modern languages, because they're like very much different spheres, I guess, regardless of how you look at it. I'm like learning about machine learning completely separately, at least, in a non-compiler context, just because it's like cool, to be honest. Like, I don't really think there's I don't think I really need to justify why I wanna learn about it. It is just like genuinely really cool in my opinion. Machine learning, yeah, okay, fair enough. There are like compilers for machine learning models, so that is like one avenue of, I guess, future work I could work on. That's not my focus right now, but it's something I've like looked into a little bit in the past. Okay, what am I doing here? So these register nodes are all virtual registers, I think. So I think we could kind of just take virtual register, right? That might actually be a little bit better for reuse, because then we can just keep the pointer instead of like making a new register. I might actually do that for all of these. Yeah, yeah, this seems like a good idea. Yeah, okay, let's do that. So then we can update. But then this would make like chaining really annoying. But I guess this is probably fair. Does compiler design or research work the same way ML or cybersecurity and crypto do? Yes. Or cryptography, not crypto. Although that also does. But yeah, compiler design also has a lot of research. There's stuff about, it's all just about like making optimizations better for the most part. There's also some like compiler security stuff that exists here and there. I haven't looked into it too much. The big hot topics, aside from like compilers for like machine learning, the big hot topic is like, I think improving like auto vectorization. So there's like some assembly instructions that are like, I guess they perform an operation on multiple registers at once. And the problem is it's really hard to get compilers to generate them. So there is like a lot of ongoing research on just like improving, I guess, the ability to generate code for code that uses those sorts of instructions. Okay, let's do the thing. Let's replace get name with virtual register star. Yeah, we can do that. Or maybe we make this like get putter? No, we'll have collisions, I think, that way. I think this is the least convoluted way to do this. Yeah, so let's just keep doing this. Huh? What's wrong here? Am I blind? Huh? Oh, I can't call it register? Okay. Why can't I call it that? Oh. Right, yeah, that's a collision. That makes sense. Let's go blueberries. Or skills. I don't know what you want me to call you. But yeah, day 100. The final went well, I thought. Yeah, the exam was harder than anyone expected, but like the prof gave out a couple hints. There were like a couple tricky questions, but I felt pretty good about it at the end. Let's just make this like get LIR. Okay, we can. I don't like LIR here. We can just make it register. Yeah, okay, that's fine. Yeah, we use reg a lot, so this is fine, I think. Okay, we wanna change up immediate node real quick. We also wanna change the constructor for this, I think. Do we want to? Yeah, I think we should. I think we should change the constructor to just Do we want this to just take a register node though? I guess we could just take a name because these are interned anyway. Same for this as well. New security files, compiler optimizations, ML, and cryptography sounds cool, but doesn't make as much money. Yeah, that's fair. Well, actually, you might be thinking about that just from like a strictly academia perspective. There's also like a lot of large companies that do have researchers for these sorts of things. Like, I'm sure you've seen all of the memes about like ML researchers making like crazy bank. I think like that's kind of like the tip of the iceberg at least. Okay, let's actually undo all these changes. I think I will keep it like this for now until something truly changes my mind. That doesn't answer a question of how I'm implementing address node though. I think I will just take the same values and then we will make an address out of it later. Or actually, we can just take nodes for all of these, right? Honestly, we could do that. Yeah, actually. All of a sudden, that doesn't sound like a terrible idea. What are we doing currently? I'm working on instruction selection, and there's a lot of abstractions that need to be made here. So I have like an optimizer language, and I'm trying to turn it into assembly, but they don't map one-to-one onto each other, so I need to like do some like funky conversion work pretty much. Is it complex? It can be complex. I feel like I've overcomplicated it a little bit the more I look at my code. Yeah, so I've made a mistake somewhere, but it is what it is. Okay, maybe we should... I kind of like this, actually. I think this will... Will this deduplicate? I guess no. Yeah, it really doesn't hurt to just keep these as it was. Address node, I think I can just... Are you using LLVM? Not quite. I'm like making an LLVM clone mostly. Okay. This is a little awful. Do you have a whole map of assembly instructions? What do you mean by that, at least? Also, I'm throwing this into ChatGPT to figure out what I should replace these to-dos with, because if it wasn't obvious, I'm struggling to think about this. This doesn't help me. Oh, actually no, this does help me. Oh, actually this makes complete sense. We could, let's just use strings here. Let's replace registers with strings. Let's replace immediates with just values. Yeah, that seems reasonable enough. Or immediates with uint64s, I guess. We can do scale, we can do displacement. List of assembly instructions, yeah. I guess similar to how we have like a memory representation of like all of our other languages, we're also gonna need a memory representation of the assembly as well. That at least is like the cleanest way to go about it, I think, because then we can also do other things with it potentially. So I do have kind of a list already built out. Yeah, it's in LAR instruction. There's like a bunch of instructions here. Feel free to just like dig through the repo at least. It's all public. Yeah, okay. This seems quite reasonable actually. I like where this is going. Do I like where this is going? Huh. Yes, I do like where this is going, because then we can like merge addresses in some capacity, I think. Are you building this for your portfolio? Partially yes, but mostly I just want to learn about all this stuff because it's all really cool. Actually, how would this merge with the tree? I guess let's look at the big textbook. It's this book. I know I said I don't really like this book a lot, but it at least paints a pretty solid picture, I think, so I will look into this. If you want to expand it, it'd probably get long. I mean, there's no other alternative though, right? Like, I think the memory representation of all the other parts of the program are definitely just as long, if not longer. And like, yeah, like, either, like, it is inevitably gonna be long, yes, but there's like not really any good alternative, at least. Like, length isn't really something I'm that concerned about. Worst case I figure out a way to like break up the program into like smaller units, which is like whatever. Length is only a problem insofar as like the source program like fits into memory, and like if that doesn't fit, then like it is what it is, I guess. Are you wearing IMs? Yes. I keep having to look at what they're the 02s. Like Critical did a collab, I think, at one point. Okay, where is the section? Alloc, scheduling. There we are, okay. Okay, this will inevitably be a little bit hard to see, but apologies. Yeah, maybe we should make this mergeable in some... No, actually... Huh. My concern with making this mergeable is that, like... This isn't really something we can, like, simplify, quote-unquote. We have to have, like, a boundary at the register, I think. But I guess we could kind of enforce that in a way. Yeah. This is tough. I think register allocation, or no, instruction selection tree tiling. I'm gonna look at these Cornell slides. Are these even helpful? Ah, yes, okay. This is actually very useful. Okay, so we can compose memory into tree structures. I guess I don't really have a lot to be worried about here. I can make these immediate nodes as well. I guess we're not really merging the immediates ever, so this should be fine though. So let's just do it like this. So this takes node star, or we can add those after actually. So this should take unit score t bait scale. And we can do that. Yeah, and we need to make the nodes before, so we can't really like just pass them in, I think. Or like we can, but it'd be like annoying. So I think this is fine. Although, I guess we only construct them in there, so we can kind of... I think it's probably fine to just like take a node star in here. Yeah, we can do that actually. Congrats on day 100, thank you. That's fine. This we need to, we can just take node star base, node star index, and then we can leave the rest as is for now. We do need to add a visitor, I fear. It's looking more and more like I'm gonna need a visitor of some sort. But if I don't, then it's like it's fine. Oh, I'm gonna need it for print. I need it for print. Why are these unique pointers? Oh wait, yeah, these are unique pointers. Yeah, so we need a unique footer of node for that one. I now remember why I didn't want to do this, because this gets verbose very quickly. Yeah, like this looks very sloppy, unfortunately. It is what it is. We can also get rid of these setters then, I think, even. The only instance we need to set will just be, it should just be in, register node, I think. But I'll wait to get rid of them. Is discrete math hard? I thought it was fine, honestly. I think a lot of people think it's hard because, it's like the first, I guess first class that teaches a lot of people that computer science isn't just coding. And a lot of people just struggle to grasp that concept, and they struggle with it for like a really long time. But I think it's like fair. It's very much just a math class. That's the thing, I think. Okay, so this should be source, and then instead unique footer of node footer. Logic can be hard to grasp, but once you get it down, it's just taking the time. Yeah, that is kind of like where my take on it ended up being as well. I think like a lot of the dislike for it is kind of overblown, in my opinion. Okay, let's clean up all of this slush that we left behind here. Stood footer node. This is source, I think. So name, and then source is source, or stood move source. Yeah, we're back to generating boilerplate. Man, that sucks. Okay, so register is fixed, immediate is still fine. We need to add both of these real quick. V visit this. We need to implement this real quick. We have index is the move. Oh wait, I forgot to. What's wrong here? Am I dead? Brain damaged? What is wrong here? Oh, I see. Whoops. There we go. What? What am I missing? Oh, why are these node star? Wait. These are stood unique putters. Whoops, 1 second. There we go. That's fixed. Friend does have basically no use for discrete. I disagree. I think just like, first of all, I think it helps a lot with like reasoning about data structures. And it's more about like the thinking that goes into it rather than like you can directly apply it. And second, I think like I feel like it's hard to really, I guess, I feel like it's not really like a argument to start with, because like the point of a computer science degree is specifically to like get a stronger understanding of the theory. It's not necessarily to like become a programmer, right? Like getting a computer science degree with like the sole intention of just like getting the skills to become a software engineer is like getting a chemistry degree to like learn how to bake, right? Like it just, the point isn't like, it's not supposed to map 1-to-1. I think the value of a computer science degree is in the theory, and if someone says that like the theory is not valuable because like it doesn't apply to what they want to do, then fair enough. But also like I feel like that's like you're going into fine dining restaurant and complaining that they don't have donuts, you know, like it's just like kind of, it feels like a non-starter to me, at least. I actually like discrete because a lot of its intuition reasoning. Yeah, that is like how I thought about it as well. Do you find TMUX easier or more convenient to use compared to WestTerm? I find it more useful because of the persistent sessions, so I can just detach the terminal. This is useful like both locally if I just want to like nuke my terminal and like pull it up just to like help manage the window mess a little bit, or more importantly if I'm like working off of my research server. And like I'm on a laptop, so like it's useful if I want to like switch between laptop and like PC for connecting to it. And it's also useful because like Eduroam is crap, so sometimes I will get disconnected and I will be very happy I have a persistent session to keep my work on. Are you using GDB for debugging? I use a Neovim plugin for like my debugger, but that is running code LLDB, which I think basically wraps GDB. So, or it might wrap LLDB. I'm not sure. I think you can kind of just like pick which one you use. Ironically, I think it wraps LLDB, but there's functionally no difference between the two, at least. Just one of them is GNU flavored, one of them is LLVM flavored. Underscore, hello, thanks. So that left is the move left. Yeah, I love writing boilerplate. This is right now. There we go. Yeah, I truly just think that like, I think a part of like why I don't understand the complaint is just like, I feel like I just don't understand the people that think CS degrees should be a software engineering training. Like, I feel like that's kind of more of the point of a boot camp, right? Or like, I guess like it also just feels kind of wasteful to like get a CS education just for the sole intent of like becoming a web dev. But that's just my take, at least. Okay, that's fixed. Let's write this constructor real quick. Yeah, I think this will compact my code a little bit as well. Not here, but like later on, at least. So that makes sense to me. Like, I feel like people are kind of like, I guess CS like lives in this like weird middle ground where like it kind of occupies like this sort of space between like what like I guess more like higher education-y based pathways like law or like med school would occupy, and like something that business would occupy where like it's strictly networking. It feels like CS, I think, I don't know like how to remedy that. I think any comparison to the other two is like kind of inorganic though. Yeah, I think that's also not to say that like there's not space for like software engineering skills to be built in computer science educations. I think like I think it's valuable to have some sort of like applied sort of classes. So things like classes like, I'm just gonna like speak from like my school's course catalog, so like something like agile or like full stack software engineering, just like those sorts of classes that are like a little bit more practical. I personally like, I would not take them because I could kind of just do them externally. Well, except for agile, that one like is kind of different, but I think like there is definitely a place for them, but I don't think they should be the sole focus of a computer science education, at least. I guess that's like my take on it. Okay, let's okay, we're gonna, I think that fixed all of that stuff at least. Let's build real quick. Oh, this is gonna break, huh? Yeah, okay. Let's add this real quick. What do we do here? Add proper constructors for nodes plus stuff for mem address node. I guess while I'm at it, I could refactor some. Nah, we're keeping a register node. You can fight me on that one. Yeah, it is a little bit of a self-reinforcing problem, that is true, but I don't know. I feel like I don't know. It's just kind of like a messy space, regardless of how you look at it. Oh, we do need setters actually for this, I think. We can just give this null pointer for now though, luckily. So we can do this. We can stood move left, and then stood move right. Yeah, this compacts down nicely, actually. We'll do this. And then we can take stood move up. Yeah, okay. I don't hate this. This seems fine, actually. Yeah, these getters, I'm not really sure how I feel about. I feel like they might just have to be a ref to the unique pointer, but I think this is like reasonable enough at least. Field's wide enough and I'll have interest within it, I'll be able to find something I want to do. Yeah, I think that seems like a pretty healthy way to go about it. Yeah, okay, so we actually don't need a lot of setters here. if we compact it down like this. Guess we could compact these like this. Nah, we should keep the spacing the same. Okay, this is the other one that needs to change. Let's take source. Which order does this take them in? This is important. Take source and then putter. Okay, cool. So that fixes everything. You can probably get rid of a lot of these setters actually, because I don't think we will be modifying them, at least. We might want the getters actually. We might want the getters to become unique pointer refs eventually, actually. If we're like dismantling the trees. That might be something to look into later. But I'll probably save that for another day. That one needs a setter. That one definitely needs a setter. Does it need a setter? That would be in merge trees, right? Oh, no, wait, no, we don't? Wait. Oh, we only use consume. Oh, wait. That's rather interesting, actually. Okay. So, where's our consume implementation? Yeah, I don't think we use set source. Yeah, we just don't use it. Okay, we can get rid of all of our setters. That's cool. Yeah, let's do cleanup work. Or that one we need a setter for. That's the forest. Okay. Get rid of that. Okay. Cleaned up. Okay. These instances of the word set are good. I guess I could change this real quick. Let's node star or slash star. Let's add a space in front of it to. Oh wait. Let's add a space in front of it just so we can check which ones. Yeah, that makes sense. I'm not excited to clean these up. Okay, we probably need a getter for these anyway. So let's replace these with stood unique putter of node and then a ref. Ref literal, yeah, like that. Okay, and this will be useful because like when we're tiling the tree, we want to, I guess, like we want them to overlap by one node. So the way we recurse on it is, I guess, we just take whatever's left and then we just like eat it, I guess. That's a very convoluted explanation. I'll explain it later. Once I get to that point. Okay, so we need to like do something similar here. For 6 substitutions, we can just return source here. Yeah. Yeah, this also compacts our code. Okay, so that cleans all of that up. Let's try that again. let's add that real quick. Update tree gen with constructors. Low-key, I'm low-key just gonna be like farming commits today accidentally. Yeah, small commits are like technically the correct way you should do things anyway, just because like then like your changes are more descriptive and you can walk through your Git history a little bit more cleanly, in a more cleanly way, I guess. Replace getters with unique footer getters. I promise this is important. Oh, we need to add them for the address node actually. Let's do that real quick. We need that. Index. Let's steal this line actually. Scale, we need displacement. Okay. So that's there. Let's implement those. Let's go to Isaiah. I feel like I haven't seen you in a second. I am still on instruction selection because this is really difficult. It's a wonder that in the class I took, I managed to get this done in 2 weeks. I'm very fortunate to have done this once, so I'm not completely lost, but I'm still quite lost if it wasn't obvious. So, yeah, we're all in this together, you know. We are in this together. Yeah, let's do this. Oh wait, this should not be base. This should be index. Yes, I'm leaving the formatting ugly for a second. There you go, all formatted. Alright. Let's update the commit real quick. Okay, all of that is in one commit now. Okay, so now we can add more things that I forgot about, such as toString, because I need a toString. Fuck, okay. We'll implement numeric tricks like the bit rotation to multiply by 2. Oh, I see what you're saying. That'll be at the middle end level, yes. I think I'll do something like that in like a canonicalized path, but I need to like determine what the canonical form is even going to look like. So, yeah, that will be a future issue for me to worry about at least. But yes, that is something I will get to at some point. Okay. So what is sort? Oh wait, I don't need to change any of this code. That's really cool. I do need to add the address node. Stop being mysterious. Yeah, I mean, there's just a lot for me to like. There's just a lot of moving parts in this project, which necessarily means that I guess things will be a little bit left in the dark until I get to a point where I can properly address them. It's funny that I said the word address because I was writing address. Of course I did. Okay, we need the implementation of the visitor real quick. Oh, this is not gonna be fun. This should be address. I guess we can. Oh no. Oh no, okay. Okay, we're gonna need to visit some nodes recursively. This should be. Oh, wait. There we go. So we want base, I think, comes first. I guess it doesn't really matter, but still. Oh boy, this is yeah. I'm going to make a mess. I'm factually going to make a mess here. This was quite useful to look at least. No. Okay. See, we will break this we will break the quote unquote tree, but that's fine. They can deal with it. So we have base with index. Okay. Okay, let's do 2 more of these. This should be scale, this should be displacement. Target scale. Or wait. 2 strings get scale, or n get scale. And friends. And we can just steal this. Okay, so let's fix this now. So we want base index plus that scale plus that, and then plus displacement. Yeah, that's fine. Okay. Add address visitor plus 2 string. Just node. Okay, so that's that one. So now we need to, I guess, fix everything else now. This does not bring me joy. So now we have to worry about alloca. I have no idea what to do here. Oh boy. How do I even do this? I think I need to add more stack space. But then how do I do that? Or I guess stack space doesn't really make sense here, at least. I think we could add stack, or we could add like a virtual. Yeah, we could add some sort of like a virtual sort of instruction again. Where does this live again? In instruction, yeah. So we have this virtual sort of, I guess, decorator, which is interesting. Yeah. Also, I should get rid of instruction unknown. This is stupid. Why did I think that was a good idea? Get rid of that. Let's get rid of that real quick. The visitor, her instruction unknown doesn't make sense either anymore. We can get rid of that. We should just put this in generic instruction. Yeah, I think that's fine. Okay, that doesn't answer my question here. What do I do here? What in the hell do I do here? So I need to fix these 3 to-dos. Maybe I could also just generate the preamble somewhere else. Seems a little bit silly to do here. What am I doing here? No, allocating stack space comes before or after, actually. Wait, what am I doing? Wait, okay. Okay, so this, we're saving the caller save registers. Here. Wait, why am I allocating stack space here? That doesn't make sense. No, this does not take stack space here. I'm fairly sure. Right? Or... Let's look at the calling convention. That's not very readable. Oh, that's not very readable. Oh, that's kind of readable. Oh, this is like a Rust book. That's pretty funny. I should use Rust book for something. I can't think of anything I would use it for though. Okay, let's round x86 cheat sheet. This is just the go-to source for me. It's a very simple way to look at it. Save registers, allocate stack space. Yeah, okay. Dynamic stack allocation does not seem fun. I don't think I need to worry about that ever. Okay, let's just ask ChatGPT. This will be way easier than searching through sources. In x86, 64, do I... Does the caller or callee... Okay. This is a stupid question. It's obviously the callee. Oh, wait. Wait, what? Oh, wait, oh yeah, okay, that makes sense. Okay, so I need to allocate space for that. $16 stack. Oh lord, I need to worry about that. Oh, that's really annoying actually. Oh, the Microsoft API is different. Damn it. Okay, I'm not gonna worry about that. We're just gonna assume Linux. We're just gonna assume this. Okay, so I need to worry about that somehow. Okay, and then yeah, okay. So I still do need to like worry about allocating some space here, I think. Or actually no, push is fine, right? Right? Can't I just do that? Does caller need to allocate space if it's just using push? Yeah, okay. So I'm not going insane with that one. Oh, I need to worry about that. Damn it. Okay. After. Okay, yeah, yeah. Alright, that actually makes a lot of sense. So then, how are we worrying about this? I guess. Oh, also, it seems a little bit stupid to just use the full-size registers, at least. So I should probably also fix that as well while I'm looking at this pile of slush. Okay, starter function, so this is preamble stuff. I need to allocate space somewhere here, I think. Right. So we need to allocate that there. Okay. Yeah, okay. That's very annoying. Do I need to actually? Because I could just push, right? No, I probably should allocate it. That'd be faster. I think I don't need the full quadward pushed as well. Right. Fixed alignment after. Oh, that's really annoying. I hate NDNS. This is this is more of a mess than I ever wanted to worry about. But I mean, I guess it's kind of expected. I guess I could worry about that later. This I definitely need to worry about right now. Yeah, okay. That one I don't care about right now. Like, I will worry about it, but not yet. Ah. Got distracted in discrete exam this morning, dropping that course fair. Yeah. It's not easy. It's definitely a rough class, I would say. Actually. No, this is a dumb question. The callee should allocate space, I think. Instead of just pushing everything, I think. Actually, I guess it's worth asking. Okay, well, I guess I will need to worry about this, so... We definitely have local variables. We definitely do. Okay, let's figure out what the hell to do here. We could also just count allocas on the entry block, because we're hoisting all of the allocas, I think, right? Or at least that was a change we made. Let's look at the tests. Yeah, so if we look at the MR output, yeah, they're all hoisted to the entry block. So we get that sort of thing, but yeah, that could be useful actually. I probably should do that actually. So that will just come after the start function pretty much anyway, right? Or yeah, because we have a label there. Yeah, so we make the label. And then yeah, this is part of the preamble. So I think it's fine to just leave this in the allocates, honestly. And we could do like a... We could add like a... I guess what type of instruction would that even take? Yeah, we could just like add a virtual stack pointer push, and then we could do all the like merging of it later, I think. Yeah, we could do virtual for now, because I don't even know if we like need all of these temporaries. So I think we could just leave it as like quote unquote virtual for now. Okay, let's give that a try actually. We will generate a lot of assembly blocks, which is gonna be really funny, but so it goes, I guess. We don't really care here, at least. I think this is the most scalable way to do this. So what would I even be doing here? How much stack space does each thing get? I swear I had this in the test, right? Or at least in the expected. Yeah, okay. So we have a size type, so we can convert that somehow. Right? Right? We can convert that. Yeah. So we subtract, right? Or yeah, we subtract. Okay, let's do this. Let's do... This is an instruction. Oh, I don't have subtract yet implemented. Oh, okay. All good. Let's add subtract real quick. So we need to uncomment out subtract and add, I think. Yeah, those are very necessary. I don't know how the hell I have these sorted, but okay, let's close that out. What does subtract take? Oh boy, I'm excited to read this. Are you excited to read this? Oh no. Oh. I'm sticking with this. I'm lazy. I don't wanna touch that with a 10-foot pole right now. One suffix, okay. So we want a... Yeah. Want a data size there as well. It's just size. This gets a private. This gets public. We can just steal the usual stuff and put it here. So size, we have brand, star, source, and then destination. Okay. So that's add. We can kind of just do the same thing for subtract, right? Feels a little bit stupid to duplicate this though. Huh. I guess I could just add an enum for this, but that might be smart, huh? Well, I'll separate it for now. I cannot be bothered. Okay, so we add and sub now. So we subtract. I don't think this verbosity is inherently bad, but we'll find out very quickly. Oh, it might be bad. I've already thought of an instance where it's bad. Okay, we're just gonna simplify this a little bit. This should be. So we just do like binary op, I guess. We can do bin op. So we want a new thing to add here somewhere. I want like. Yeah, this we're gonna reuse this again. Op, I guess. And this should be an enum type again. I'll just throw it here for now. I can do that. Yeah. Okay. Alright, that's not the end of the world at least. Bin op. Binary op. Let's be verbose, shall we? Yeah, it must be really frustrating to watch me write code. It's like I like go back and forth on design decisions every like 10 seconds. It's just like a really bad habit of mine. Sub, and then what do I do with data size? Oh, we have a from MIR. That's nice. From MIR. Oh boy, this is okay. So this should be I get alloc type. Oh wait, no. This is an I64 type, right? Oh, god damn it. Okay. Are we there yet? We are not there yet. Unfortunately, we're quite a ways away from being there yet. What do I do here? Okay, let's give it LR data size quad word. I think that's the pointer size, right? Oh wait, yeah, of course it is. Of course it is. We're using the 64-bit register here. So we're applying it to dest, right? Is that how I'm reasoning about this? so RSP. Oh, fuck, okay. So let's get... do this, let's get RSP. So we need RSP, and then we need a way to get the size. We can just hard code this for now. Unhard code size lol. Actually, is there a alloc size thing? We don't even have like an alloc size thing. That's annoying. So I guess we just add like... Wait, all of our allocs are 8? Why are they 8? Godbolt. Is 8 even the correct... Or am I just like brain damaged right now? Oh, this is 1 dash? Yeah. Oh, wait, no, duh, it's I-32. Okay, so we allocate for... get immediate. This takes in a value of 4. Okay. We get RSP and then size here, right? What do we subtract from what? Is it true that most CS students can't program on their own? I think given if you absolutely force them to, I think they'd be able to. I think the more accurate statement is that most CS students don't program on their own. Like, they're physically capable of doing it, it's just they don't spend the time to do it, at least. Yeah, I mean, that's kind of just like, I think that's kind of a symptom of the whole like computer science as a education, or like computer science as a software engineering education sort of mentality. Source from destination. This is backwards. Whoops. Size RSP. So we scroll down. That should confirm it. Yeah, number first. Let's do that. Okay. So we need to push this onto assembly real quick. Or instructions. Push back, allocate. Or instead move, allocate. There we go. Okay. This should be wrapped in a virtual, actually. I guess this should be... Yeah, let's make a auto virtual allocate. Yeah, so then we can like handle this in a more interesting way. This takes to move, allocate. Okay. Yippee. You value someone who codes than someone who doesn't want to? Yes. I would value someone that writes code more. Or I mean like, this gets into like weird like who has value things. If I were like picking a candidate, I would pick the person that, like if I were hiring for a job, I think it is a lot easier to justify hiring someone that writes code in their free time than someone that doesn't, I guess. Hmm. I should put a virtual add up, I think. Okay, we should add another thing to the visitor real quick. Let's go to gen trees again. We want what am I calling this? Alloc space or allocated or stack space. We can do that. We can just do that. We can merge these later. But this we would want in one place, I think. Most guys just think they're entitled for a job immediately. Yeah, I mean, it's like, again, it's like, I guess the direction computer science is moving, or at least like software engineering is moving, is like, it's like more and more into the, what do you call it? I guess like more businessy sort of direction, insofar as like, I guess the way industry works with it. Like, there's not really like, I guess like it's well defined how not well defined it is, if that sentence makes sense. Okay, let's make a, let's steal this again. I should probably add some comments around here. This is such a chunky program. Okay, so this should take stack space. That. Deallocate. Add. This should be virtual deallocate. Deallocate. Yeah, people definitely could write a lot more code, I think. Like, people are definitely capable of doing that. It's just like, a lot of people are like very preoccupied with other things, which is like fair, but I don't know. It's just like, it's kind of one of those just like tough things you kind of just have to, I guess, witness occur. Yeah, this is fine. How are we dealing with alignment here? Actually, let's add a... This is greater than 0, then we want to do all of this. We need to initialize this as well. It just occurred to me. So we can do that. Maybe I should start commenting things. Yeah, let's start adding comments. Or function label. push call the saved registers. Just as a hyphen. Will a single board computer have to use a cross compiler? Yeah, like I think a lot of like people are just like, I guess they aren't willing to put in the effort to learn, which like on one hand fair enough if like that's not what you're expecting to do. But on the other hand, it's like it's not that difficult if you just like even remotely try, it feels like. Okay, so this, what are we doing here? So this is moving function parameters, or moving what the hell am I doing? Wait, what the fuck? Oh. Unmoving. Or move parameters to virtual registers. Jesus Christ, what am I doing here? I can do that, I guess. This is so stupid. What was I thinking? This is a really bad idea, isn't it? I feel like I should directly take the registers then. Yeah, I definitely should do that. This seems really dumb. Yeah, let's just do that, I guess. I'll worry about that later when I actually have to allocate registers in some way. Because I think what's going to happen is we're going to have a... If we get to the point where we have like 8 parameters, we're going to have like a push, and then we're going to like push it onto the stack, then we're going to pop it off, and then like we're immediately going to like push it back on because we're out of registers. It's going to be a mess. I'm not excited for that. I've always wanted to do more embedded stuff. I think I like thought I would get to do a lot more of that in like Solar Car, but in reality I'm kind of just like working with like radio stuff, which is an interesting outcome, but I don't know, it's not really what I expected, but it is what it is, I guess. I can't really complain. I need to reset something at the end of the function. Or do I have like a reset function? No. Actually. Oh wait, this is the reset. I see. Okay. So we reset forest. Stack space equals 0. We want to just clear that as well. Okay. I don't think that needs... Okay, I don't think these need comments. think this is fine as well. This is fine. Most of this is pretty fine. This is not as fine, I think. I should definitely comment this. This is push, caller, saved, registers. We got to move. Args to parameter registers. Or yeah, we can do that. I want to do that. Call. That. Restore, caller, save registers. Right? Is that what I'm doing here? Alright, no. I'm doing that here. And then here I am... Oh god. This is verbose. Move. Return value to virtual register. Okay. Okay, I think I've cleaned up most of this, at least from a readability perspective. It looks like I've not cleaned it up from a readability perspective. Oh boy. You complete DSA? Yes. I completed a while ago actually, I would say. Yes, we can move return. I guess, yeah, we can just keep this as that. Allocate stack space. Oh, but yeah, we allocate it somewhere else, so that doesn't really map one-to-one. Small capacities didn't help with noise spot slurring is bad. Happens. I do not understand electrical stuff at all, so this might be a little bit beyond me, I fear. Save that. Return Lamau. Okay. I think we cleaned everything up. This looks very solid. Do I need like... I like this sort of logic. Yeah, okay. That seems readable enough. Oh boy, what did I do? Okay. You do the background? Yeah, I mean, it's all, I guess, one continuous chain. I have a couple of friends that are just like complete CE gods, and like, they do like crazy stuff. Like one of them is like designing a GPU right now as a side project. One of them is like making a split keyboard completely from scratch. Like designing the PCB. It's just like, holy hell. Code looks clean, but maybe it's just the color theme. I guess it's a little bit of both, I guess. I'm trying to like make it readable, but the fact that I can't read my own code means it's definitely not readable. Or at least before these comments. This is just like, these are just giant functions that do not fit on one page. The correct thing to do is to split it up, but unfortunately, I think that would make more of a mess. So we're just gonna keep it as one mono function. Okay, let's add Star lir dot star unknown instruction was stupid. Great commit, by the way. Incredible commit from me. Okay. What did I change in instruction? I added add and subtract. Or actually, how do I get add part of file? Let's add. Let's add that. What the fuck? Okay, yes. Stage that. Wait, what? Oh, I didn't implement anything. Okay, header, this matters a lot more. No, I don't want to stage that. I want to stage that. Stage that. What the f... Okay, sure. This is stupid. I need to clean all of this up later anyway. Okay, we can amend that. Okay, this also made me realize I need to implement the stuff for the new instructions I added, so I'll do that real quick. Okay. It's just these, I think. There's not really anything to implement here, actually. It's just those two, to be honest. Okay, I got rid of unknown. Thank fuck. Where's pop? There is pop. Are all firm believers that math degrees can get into any role? I think so, yeah. I think the big thing is that math teaches you how to learn, at least. And in that sense, like, it's all very flexible from that point forward, I feel like. Yeah, this constructor is not particularly interesting. Let's just steal this boilerplate again. Oh, that's too much deleted. There we go. Oh, wait. There we go, okay. Okay, so now this is just the new stuff. Nice. Add, and sub lol. Yeah, so we add comments and we add stack space stuff. Add stack space, stack, or we do that, and we add some comments because I kept tripping over my own code. Okay. Okay, we got 7 commits. That's a little bit farmy. Okay, so that cleaned up all of that. Can I just... What happens if I just try to make now? Ah, crap, okay. What's wrong here? Instruction on... Oh, yeah. Yeah, that doesn't exist anymore. So let's enter tile trees. Let's just do that. Maybe I should just get rid of that. And then let's get rid of that. It's a ref? Yeah, that should just be a, I don't know. That we shouldn't be in this point to begin with, to be honest. Okay, maybe I should add like a constructor just for like base instruction as like a default. Okay, so let's run debug and panic on test, regression input. Let's give it like call chain. Okay, interesting. Yeah, this does exactly what we expect it to be fair. Yeah, okay. Yeah. Yeah, it's just a bunch of pushes and a bunch of pops, which, I mean, yeah. That is completely fair. Where's the stack space stuff? Okay, well, is there a simpler test I can give it? Maybe like just pop. Oh, I know why. Dash O 0. Okay, we get unknowns now, which is expected as well. Where does our two-string stuff live? Oh, I know where it lives. It doesn't live. We need to add binary op to the visitor. Okay, so let's go back to instruction real quick. Push pop binary op. Oh hey, that rhymes. Anyway. Binary op. So we can do that. We need to implement that real quick. So we can do that, and then we want switch block on I. Yeah, we can. This actually shouldn't be that hard to implement, I feel like. Yeah, we should. These are definitely not hard to implement. I could do this real quick. I also have a final to study for, or not a final, just like a large exam that I should study for. Yeah, let's do that real quick. I'm just gonna do this for now. If this works, then like, cool. If it doesn't, then like, whatever. And by whatever, I mean I will fix it enough to the point where it prints something. Applied math, ooh. That's a fun major. I feel like a lot of applied math people I know are quite smart. Bin op, okay. That does what we want it to. So this is going to return this dealloc space, and it's virtual. That's good. Yeah, this output looks like a mess for now, but I promise it'll get better. Why is there so much? Oh, that's the entry block. Okay. Is that the entry block? Yeah, that's the entry block. Yeah, we'll just leave that as is. Smart too? I mean, smart's a relative term. I still have a lot to learn. I'll say that much. What did I change now? Binary op. Why did I change an instruction? Oh, I see. Okay. Make it compile, and then add visitor for binary instruction. Okay, that seems like a reasonable place to, I guess, end today's stream. Once again, thank you all for being here for 100 days. It's quite incredible to me that my channel has grown this much across this time, and it really does mean a lot to me. If you're new here, make sure you sub to my channel and like the stream. Yeah, that happens a lot with that happens a lot when I'm debugging things. I magically do just think of the answer. Yeah, make sure you like and sub. It helps out a lot with the algorithm and gets my content out to more of you. Also down there is my Discord. You should join. Everyone's quite chill. We talk a lot about NeoVim. It's pretty funny. It's also the best place to get pinged when I go live because YouTube's notifs are all over the place. And of course, the big other thing in the description is my LinkedIn and my GitHub. Feel free to add me on both of those to stay up to date with what I'm doing. Yeah, I'm gonna get a little bit of food and then study for this quiz tomorrow. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.